I'm going to be talking about the electric vehicles, and I'm going to talk in particular for the built environment. I know there are attendees that are very acknowledged in fire, and there might be others that are more in the built environment, but not only on fire. So I will try to make it as friendly as possible. Feel free to ask any questions. And so what are we going to look at today? So first, I'm going to talk about the emerging risks of EV batteries on fire. And then I'm going to talk about the technicality and why it is a challenge, why we're talking about battery fires and not of fires overall. Then I'm going to talk about some recommendations for charging points that are very important, are very linked to the vehicle itself. Then I'm going to give you some design guidance that has been recently published and recommendations that we normally follow when we are doing our fire strategies, when we are thinking about EV fires. And then I'm going to give you the conclusions. So the emerging risks. Here you can see an e-bike that went through a fire. It was basically almost destroyed. So there are a lot of hazards going on. The first one that I want to talk about is gig economies. So if you haven't heard about gig economies, that's fine. Basically, are these economies that they do delivery of food, of groceries, and it's basically not to mention brands, but for you to have an idea, Uber, Deliveroo, all these type of companies. And then why is it important for fire and EV vehicles? Normally they have lack of benefits, and also they have high reliance on e-bikes or e-scooters. And one of the things that has come up in surveys, research on these gig economies is that, for example, they have lack of health insurance and sick pay, which makes them work even when they are sick. They are not in the best conditions, unfortunately. They have, in the UK, they earn 52% less of the minimum wage. So that's a very significant amount. And 42% of these gig drivers have damaged their vehicle in collision. So all of these factors lead them to want to have high-speed chargers because they need the vehicle to be working as much as possible, as fast as possible. Because they don't have a strong income, they have their vehicles in poor conditions. They normally use cheap chargers, which are not the chargers of the manufacturer. This is another problem. And also they adapt bikes or scooters that were not really manufactured for that. So they are do-it-yourself. And that brings a very big problem because many of the e-bike and e-scooter fires are because they were not properly used. The other one that I want to raise of the hazard, disadvantages, problems that we have is that most policies in fire address probability rather than consequences. And when we talk about fire, we want to talk about risk overall. And risk involves two factors. One is probability and the other is consequence. And normally, because we cannot design for very unlikely events, because otherwise we will be building bunkers everywhere, and we want to build normally when it's very probable that that event will happen. However, in this aspect of EV fires, battery fires, the probability is not as high as other fires. Depends what we're talking about, but in general. And the consequences, however, are very high, are way higher than other type of fires that we can find in residential buildings, in any other type of buildings that I'm going to show you some examples further on. And basically, in this case, we want to address the high consequence. That part of the risk is where we want to focus, but most policies don't design for that. So that's also something that we have to look to find the balance between not over-designing, but also avoiding these high consequence events. The other one is that right now, for fire, it's not fully regulated. So fire engineering is catching up with the technology. We are late on the detection. Therefore, we're late in the alarm. We are late in effective suppression systems. We don't have right now an effective suppression system. And we're still trying to understand how to stop these fires. Because right now we're stopping flames, but we're not really stopping the chemical reaction that I'm going to talk about in a bit. Also, that because it's not fully regulated, it's very difficult as well to find the location of these devices in the building. So when the fire brigade arrives, these devices can be anywhere in the building. They can be in the kitchen, they can be in the bedroom, they can be in the storage allocated for that, they can be in escape routes, they can even be in the stair. I've seen buildings where there was an e-mobility scooter charging in the stair. So that makes a big challenge because they are moving all the time and we don't know how many we have. So for example, kitchens are normally the biggest risks in residential buildings. We know how many kitchens there are in the building. For these ones, we don't know. We might have, we might not have. So it's a bit like, yeah, it's a challenge right now. And also we have a lack of public awareness to treat and dispose these devices. So many people don't know, for example, that you shouldn't be using chargers that are not from the same manufacturer, that you shouldn't be exposing your devices to mechanical abuse, to thermal abuse. And also when these batteries are not working anymore, they are not properly disposed. And actually many of the waste management fires are happening because of these batteries being disposed, and it's impossible basically to locate them when all the waste is gathered. That's other of the problems. We have demand for charging points because people want to charge their devices. Most fires occur while charging. That's one of the biggest problems. Locations need an assessment. So we need to make sure where are we locating these charging points. I'm going to talk about RC59 recommendations of how we can improve this. Also, we can have blocks, normal blocks, not proper charging stations, blocks near parking locations or storage locations, and this can be misused, thinking, oh, this is electricity, it works, I will plug it in, and that's not really a good idea. Also, because they use these plugs that are not for charging stations, charging points, there is a lack of safe isolation of power. So the fire brigade needs that the places where charging points are, they can be isolated from the power. And in normal plugs, it's very, very difficult to do this. So those are also one of the things that we have as challenges from the demand for charging points. The other one is that there are mass transit events occurring globally. So globally, we are having these events. It's not only in the UK. We have them everywhere, and they are happening constantly, and they are growing. I'm going to talk about fire statistics of the London Fire Brigade in a bit. So this is an EV fire that happened in a train. So as you can see, the device is basically destroyed, unfunctional, and the linings of the train were a bit damaged. And yeah, it's not a good scenario. So I'm going to talk technically, what's this thermal runaway? What's these EV fires? What does it mean? Why are they important? So thermal runaway is a self-sustained chain reaction. Basically, the electrolyte can react, well, whatever is inside the battery can react over and over and over, and it's self-sustaining. So it can run forever and ever and ever. So how does it start? So it starts when the heat generated within the battery exceeds the amount of heat dissipated to the surrounding. So once we are not having enough heat dissipated, the thermal runaway will start. That this heat will trigger it. And then in the right-hand side, you can see a battery pack, a module of an e-bike. And one of these cells, they look like normal batteries, we call them cells. And once this cell is ignited, you can see that it can ignite the left one and subsequently like all of them. So it's a domino effect. And of course, this is for an e-bike, but for a car, it is a larger pack and they have modules. So it's a lot of energy contained there. And so the more energy the cell contains, the more violent the thermal runaway. It's not going to be the same energy released by a battery of an e-bike than the one for a car. It's going to be different, the amount of energy. So the thermal runaway, why is it different to other type of fires? Because it involves flammable gases, explosive gases, and fire. Normally, in the fires that we normally have in buildings, we have smoke and we have the flames itself. Here, we're also talking about explosions, jet flames. We are talking about a more violent release of energy, and that's why they're more challenging to tackle, and also the speed at which it happens. So the released flammable gases depend on the chemistry of the battery. Normally, the batteries that are used in devices normally are LFP, lithium iron phosphate batteries, and these batteries, they will release different gases from hydrogen, CO2, CO, and it will depend on the phase they are in the thermal runaway. At the beginning, it's H2, hydrogen, that they release the most. And they can fail in different ways. They can have failure mechanisms like mechanical. It means that I throw it away violently, that I penetrate the battery with something, with a nail, for example. That's kind of mechanical failure. Thermal will be that it's overheated, so it's put in an environment. I've seen a lot of people, for example, going with their phones inside sauna and things like that. So that would be thermal abuse as well. And then electrical, that I was describing, for example, plugging into normal plugs or using chargers that are not authorized. And that's ways that we can make these batteries fail. Okay, so we have the London Fire Brigade statistics. This is something that it's very, very important because in last year, 28th of September, 165 e-bikes and e-scooter fires were recorded in London, and they were 134 were e-bike fires. So this is like 18 e-bike fires and e-scooter fires a month, and it's basically 200 incidents in a single year. So although we're talking about low probability, the amount of batteries in the world is increasing, and therefore the amount of fires can increase as well. So that's something that we have to have in mind. Before, there were not this amount of batteries, and now it's increasing. No one knows how many batteries are there in the world. No one. Lithium-ion batteries, of course, I'm talking about lithium-ion batteries. So also some of the challenges is that the detection occurs too late. We're normally in the detection systems that we have, we detect a smoke, CO2, and this is too late. This means the thermal runaway has already happened. The gases are already there, and it's too late. Basically, we know there's going to be a fire, we know, but it's too late. There are some people researching right now about how to detect the lithium plating to detect it earlier, which is one of the main points that they are trying to see, that it's how early detection can happen. But it's very, very different to how we normally detect fires. Sudden gas venting. So we have gases going out. It's very sudden. We can have even fireballs. That is very unusual, for example, to have fireballs in buildings. So that's also something unique from these fires. Currently, there is no effective extinguishment for battery fires. That's very, very important, because what we are extinguishing right now is the flames, but we are not really extinguishing the thermal runaway, which is the cause of the fire. So that's why sometimes we read in the news that, oh, there was this fire that was put down, and then a few hours later, a few days later, it reignites. It is because the thermal runaway was never stopped. It was just the flames, the violent release of that energy, but the thermal runaway itself was not stopped. So right now, if someone says, "Oh, this is really extinguishing lithium-ion battery fires," well, I think we should not try to think that it's extremely effective. It's just a mitigating measure, but it's not really extinguishing the thermal runaway. Something also that is right now under research is that the jet flames that come out of fires. So they can overwhelm the fire retardant, the lining of the building, even the structures. And there is not a lot of research. The only research that I've heard was in car parks, where it was demonstrated that the jet flame and the gases did not really affect the structure of the car park. But they were saying, for example, we don't know the interaction of sprinklers and these flammable gases, and if it will have an impact in concrete, for example, that is a very porous material. So there's a lot of on the research, really, because these fires are different than from the normal fires. I'm going to play this video. This fire happened just this year, a few days ago, a week ago, probably. It's a warehouse fire. And I will not play it every single point. I'm just going to explain a little bit so you can see. So here, if you see, we have a little bit of gassing, some gases going out. Is minute 6 with 16 minutes. Sorry, hour 6 with 16 minutes. And it starts kind of okay. And then we go to 1 more minute. In 1 minute, this is the amount of gases that you will have. In slight smoke, so probably the state of charge of the battery was low. If it's darker, if the smoke is darker, it's going to be a higher state of charge. The battery is fully charged. And then we will go a little bit more. 1 more minute, flames start to arise. The toxic gases are here. It's not only smoke, it's not only CO2, it's not, there are other things in that smoke. And then we will go a little bit further, 5 minutes. There's still the whole pack of in the warehouse is burning, and then I will go further because there is where it starts the radiation. So this box eventually will ignite, the box at the left, and let me see if I have the pointer because that might be useful. Yeah. So this one, oh, it's not working. Okay. So this box to the right will eventually ignite through the radiation. Let's see. And if you see, there are jet flames. There is this person trying to extinguish the fire. He's like, oh, actually, it's not going to work. Maybe I should just run away. We can start seeing the visibility is almost gone. The smoke becomes very, very dark. Probably there are other things being burned at that moment already. Then we have these explosions going out. The flames are going out. It's exploding. So nothing around was really probable to ignite. But because these are also exploding, the fire spread is different because we're not having a fire that we're just worried about combustibles being burning linearly. We're also caring about things exploding and the amount of time that it takes from the original source to a fireball, a small fireball, to a jet flame to go through another place is just milliseconds. It's not how normal fires travel. And then we were in the minute 16. We've been 15 minutes in the fire. Visibility is almost gone. It's starting to flame. You can see these things from the roof already fall down on the ground. And then this is basically the result. The whole warehouse was lost. It was in Poland. And yeah, that's how it started with a battery. Okay, so let's go to the next one. I'm trying to go to the next one. Yeah, there you go. So here it's in a residential building. They put the e-bike, the e-scooter there. Again, we have explosion, jet flames, very violent. Oh, the gas is starting. So if you can see why we are very late in detection, because when the gases are detected, it's too late. It's too late. We're not very near. And this is one from, hopefully we will not have the advertisement. Let me check. Oh, no. So this is a car also of gassing and then fully on fire. So the way the energy is released is way more violent to what we are normally seeing in normal fires. So these are just some examples for you to have an idea of how it looks like and why the points before were relevant. I'm going to talk about EV charging points right now. I based this section in the RC59 recommendations here. And there is also a publication from RISE in 2020 for charging of electric cars in parking garages. So that's something useful to have a look if you want. So I just put important points, but it will be useful if you want to have a look. The most important thing that they recommend is physical segregation of the charging areas from process and storage areas. So for example, here they recommend 6 meters from the car location to the storage, and then 10 meters from the EV charging point to the hazardous area zone. And they normally also recommend that it's a detached structure, so you don't put the EV charging attached to the structure to avoid any failure also structurally. So that's something they recommend. This is not, it is not regulated fully right now, so it's recommendations. It's not something you should do, but it's of course very good practice to do. They also recommend that to separate charging points with 30 minutes or with the space separation suitably arranged if it's, for example, external. You have to have a suitable power supply, control, and isolation systems. Just as I said, it's good that the fire brigade knows where are these isolation systems. It will decrease the risk of electrocution of the fire brigade. So we really want to do that. Suitable automatic fire detection and warning installations in case of fire. Here, if you see it's suitable, not efficient because of what I mentioned before. So we need detection. We need detection. We cannot say, oh, we don't need detection. We need smoke detection, gas detection if possible, heat detection. It depends on in the arrangement what you're having there. It will depend, of course. And also avoid excessive temperatures and humidity inside EV charging areas. Again, this is a way that we can trigger thermal runaway we can increase the probability of thermal runaway. So we also want to avoid these things in charging points. Also, the risk of fire increases in connection with the use of power sockets, not intended for this kind of load, and when using extension leads. So not normal power sockets, again, and no extension leads when charging your e-bike. Don't charge your equipment in emergency egress routes. I will repeat this like 5 times today because I think it's one of the most important. I have a friend that he was charging his e-bike just in the front door of his flat. And I told him not to do that. And he was like, oh, nobody will tell me anything. So I was like, oh, well, okay. Mark vehicle parking bays clearly on the ground. So that's also something helpful for people to see where it is. No flammable or combustible material should be stored with designating charging areas, as I shown in the previous slide. External charging points may be needed to protect it. We want to also reduce probably from arson fire, so we want CCTV cameras might be helpful to decrease this probability. The big challenge is when these recommendations, when these regulations, when the manufacturer recommendations are not followed, it's a big challenge. That's like a big step for decreasing the probability of EV fires. Then something that we have to do is that we recommend doing is to develop an emergency response plan to protect life and property. So if you are going to be storing any type of battery vehicles inside your premises, have an emergency response plan. Like, who am I going to call if this goes wrong? Who is the person that will do this? What's going to happen if staff going to trigger an alarm? They're going to evacuate the building. Like, all of this is important that you tell, and also to the fire brigade that they are aware where are you storing these or where are they expecting to find these charging points. Also, staff training in the safe use of charging equipment and the actions to take in the event of fire. So that's also something important to do. And then I'm going to talk about the design guidance and recommendations for the vehicles itself. So the previous one was for charging points, and this is for the vehicles itself. So the BS 9991 issued last year, I'm still in 2025, 2024, says electric charging, again, not in escape routes. That's crucial, not in escape routes. They also recommend a protected lobby or corridor of 1 square meter for non-sprinkler buildings, 0.4 with sprinklers. where you are storing electric wheelchairs, mobility scooters, bicycles, with or without charging point. Regardless, you should have ventilation. Why? Because of the gases that I just showed you. If there is a pressure buildup in the area, there will be a temperature buildup. It will cause even a more challenging fire scenario. So we need ventilation. Then also they recommend 30 fire resistance for cycle store. And interestingly, for mobility scooters, they say 30 minutes is okay with the sprinklers, but 60 minutes without sprinklers. So they're a bit more robust with mobility scooters, which is also a challenge because I understand that a person using a mobility scooter will need to have their mobility scooter not far away, of course. So that's something that we also have to address, how we can help mobility scooter users without putting their lives at risk because of fire. So that's something to look at as well. Travel distances limited in 9 meters in one direction and 18 meters in more than one direction. And those are the recommendations that requirements that BS 9991 is showing. Right now, that's the standard for fire that is giving these recommendations. It's only for residential buildings. Now I'm going to talk about car parks. Charging points should be in accordance with the regulations and recommendations from car manufacturers. So we have two things here. One is from the car manufacturers and also the guidelines of the charging point producers. So it's going to be two that we have to follow, not only who makes the car, also who makes the charging points. One of the biggest challenges in the car parks for these type of fires is the low ceiling height. Well, in general, but for these ones is the low ceiling height. Why? Because the flame will go to the roof or the ceiling, whatever, to the ceiling, and then that radiation will go back to the cars, and that will create a very, very high problem. The lower the ceiling, the more radiation. The higher the ceiling, the less the radiation. So that will help to make this scenario better. Of course, that's a challenge also because we don't want very high ceiling car parks, so we have to find the balance. Avoid charging points in large car islands or long single row arrangements. So if you have an island, a very large island of cars or a single row, don't put charging point in the whole row. At least put it in some of them, so not the whole row can go on fire or the island. So at least put it in strategic locations. For example, do not provide charging points near a smoke control supply. You can put it better near the exhaust, but not the supply, in the smoke control supply. And there are still unknown factors with regard to the development of fire, potential fire propagation, structural safety, and firefighter safety in parking garages. So there's a lot of uncertainty. There's a lot of research happening. It's moving very quickly. Last year, for example, was acceptable to put fire blankets on top of cars to extinguish it. And UL Research published a study saying actually it's not, because you are increasing the concentration of flammable gases and increasing the risk of explosion. So yeah, you're putting out the flames, but you're creating an explosion basically. So now what was good practice a year ago, it's not a good practice anymore. So it's moving fast, but we're still having a lot to research, to know. And then there is another one again. This is from RISE for indwellings. Again, no in escape routes. That's a no. Also, we are right now designing with fire growth rates lower than the ones that we observed in tests for batteries. So we're under predicting the amount of how fast it will grow, this fire. So we need to reassess the correct design fires, and this is crucial to shape the built environment and dwellings for this type of risk. Significant gas release from typical modules, and so therefore, again, proper ventilation. And the study says, this research says, in apartments, toxic gases can spread freely for a long time before any fire alarms started. So they already did this research. So again, we're late on detection. Battery modules will increase, and because the amount of batteries in the world is increasing, so the modules will increase and the risk must be managed. And also something that they mention, but there is no research that at least I could find, is that the installed domestic solar panels, they also have batteries in there. So that's also some topic that we should study at some point in fire. And there is this guidance from the NFCC, the National Fire Chief Council. And they also, again, it's a very simple guideline to use to help the fire brigade to make things safer for everyone. And they say, make a risk assessment of the storage of mobility, of where you're storing mobility scooters. They talk about mobility scooters in this one, but I think many of the recommendations can also apply for e-bikes. So again, do not compromise means of escape. Report any damage of doors, structural parts. So if there is any fire there, there's something that we can do. Something that they recommend is restrict charging at night. Again, because we were talking about mobility scooters, people that use these mobility scooters will not be able to put their mobility scooter in a garage, I don't know, in the basement. It's going to be unlikely. They will keep the mobility scooter at home. So something that will reduce the risk of this while they are asleep is that they don't charge overnight, which is a challenge, I understand, but it's something that it's a good recommendation to take. External storage solutions should be fully risk assessed, even if it's external. Again, they say because they can have arson, it can happen. It can impair means of escape as well. So it's also something to look at. They say ensure consent or permission is given to the tenants to store any mobility scooter. So that will be good because then we know where are these mobility scooters expected in the building and how many are we talking about. And then ensure that tenants have insurance cover and are maintaining their equipment in line with manufacturer recommendations. That's something difficult to do, but hopefully we will keep moving to that point. Something that is happening right now is the LFB has a charge safe campaign. You can have a look for things that you can do to make your e-bike, your mobility scooter, whatever battery vehicle you have, safer. And something that they are promoting in the US is user self-certification. So they give you a price, either a discount, or they give you something. If you, when you acquire the equipment, you make a little test, a little reading about the risks. So you are kind of self-certified and you know about the risks and you're not blindly just storing these vehicles. Restrict size of the amount of energy basically that you can store, and no do-it-yourself. Those shouldn't be allowed. And this is very important. Staff should not try to firefight lithium-ion battery fires. Just go out, because it doesn't matter if you will not suppress the flame. Like even firefighters are struggling to do that with all the equipment they have. In the Netherlands, they are trying with high-pressure jets, and apparently that's being successful for them. But again, it's not equipment we have for regular staff members. So don't tell them to fight them. As we saw in the video, the guy gave up. And then prepare first responders. Tell them, okay, this is where I'm going to have these vehicles. Just make them as more aware as you can. And then conclusions. Okay, critical risks: fire and explosion hazard, rapid smoke, and fire spread. So we have not only fire, but we also have explosion hazard, as we seen in the videos. Solutions are not yet effective. We're still catching up. We're still looking for solutions. There's a lot of research going on. There are rising incidents in London. We're reaching around 200 per year, which is not a small number. And the essential actions that we saw in depending on the guidance or recommendations: never near or in escape routes. Never. Charging areas, 30-minute fire resistance, ventilated, and not use regular plugs. For storage, 30 minutes with sprinklers, 60 minutes without sprinklers. If it's e-bikes, BS 991 says 30 minutes, but I try normally to push for 60 minutes if there are no sprinklers. And sprinklers will not end thermal runaway, but they will definitely help. Okay. And then awareness campaigns for safe charging, staff training, and emergency response plans. I think this will help a lot to avoid fatalities, injuries, and yeah, and property protection as well. And I think that's all from me.